Hi everyone, welcome to chapter 12, where we're going to learn about sequences and series. The first lesson here is about arithmetic sequences. It's probably something that you've learned even in elementary school. They didn't call it this, and you didn't write formulas for it. You were a lot of times predicting what the next value would be, or talking about how to get to values later on in the sequence. Now we're actually going to be writing formulas for this. If you haven't already, you should print out a formula sheet that is in the Google Sites, on the first page of the Google site. So you'll want to print that out so you can fill in the formulas that I'm going to show you here. So again, today we're focusing on, let me go back, just arithmetic sequences. We have two different ways to think of a sequence. One of them is if it's an explicitly defined sequence, and another way is when we call it recursively defined. Both of them have their positives and negatives, but an explicit formula allows for the direct computation to find any term for a sequence. This is actually the equation of a line. And a recursively defined sequence is a formula that requires you to know the term that precedes the one you're looking for, the term that comes before the one you're looking for. This one is not as useful when it comes to arithmetic sequences, but super useful in other situations, and it's actually what computer programs use a lot. So the way you would think of an explicitly defined sequence was we would just call it a sub n by itself, and there'd be an expression in terms of n. Like you might say something like a sub n equals 4 plus n minus 1 times 7, okay? Or maybe you'll see it as a sub n equals 3n plus 9. Okay, these are both explicit definitions of arithmetic sequences. A recursively defined sequence is required to have the first term written down, first of all, and it also then requires you to write it in terms of the previous term, which we call the previous term a sub n minus 1. So for instance, a formula for a recursively defined sequence might look like this. A sub 1 equals 4, and a sub n equals a sub n minus 1 plus 7. Okay, this would be telling you the first term is 4, and then to get to the next term, you take 4, you put it in here, you add 7. And then to do the next one, you take the answer and you add 7. This always requires you to have all the terms that came before it. So specifically when we talk about arithmetic sequences, if a function or a sequence can be defined using a linear function, then this would be an arithmetic sequence. So a line, but just terms of the line itself are what make the arithmetic sequence. And we're said to have a common difference. And this common difference then is actually the slope of that linear function. So here are your formulas for both the explicitly defined and recursively defined sequences. In both of them, D stands for the common difference. In the explicitly, you only need to write down this. But for the recursive, you have to write down both of those pieces. But again, D stands for the common difference in both of those. All right, so we're just going to start off with some basic problems. This one says, find both the recursive and explicit formula for the arithmetic sequences, and then find the 100th term. So for the one on the left, I have a sequence that goes up by 5. So it goes from 2 to 7, and then 7 to 12, and 12 to 15. So my common difference is a positive 5. You're adding 5. And when we write the recursive definition, we always start by writing a sub 1 down. So our first term, a sub 1 stands for our first term, is 2. Then we write down a sub n, and that equals a sub n minus 1, the previous term, and then plus the common difference of 5. For the explicit formula, you just write down a sub n, and then it's the first term of 2 plus n minus 1 times the common difference of 5. You are welcome to multiply that out if you want. But I actually like it in the first form because in the first form, you can find right away what the first term is. Here's your first term. You don't have to do any calculating. To find the 100th term, if you were to use the recursive definition, you would have to find the second term, the third term, the fourth term, and keep repeating until you got to the 99th term that would then allow you to find the 100th term. Not very useful, kind of cumbersome, leaves a lot of room for mistake. So instead, you're better off using the explicit formula. So you're just putting 100 in for n. So you're doing a 99 times 5 plus 2, which is equal to 497. Okay, on to the next one. These are fractions, but that doesn't make a bit of difference in the problem. I hope you can see when you look at it that the common difference here is a negative 1/2. Each term is going down by a half of the previous term. So my recursive definition will be, well, the first term is a half, and then the nth term is found by taking the a sub n minus 1 term, minus a half. So there's my recursive definition. My explicit definition is just a sub n equals the first term plus n minus 1 times a negative a half. And that's it for that one. And to find the 100th term, I'm going to use the explicit. (99) times a negative a half, excuse me, plus a half gives us negative 49. All right, next one. So this one says, given an arithmetic sequence with the fifth term, notice we're using t's here, and I used a's before. It doesn't matter, you can use either one. But anyway, we have the fifth term is 12, and the 24th term is 88. But the big piece here is to read that it says it's an arithmetic sequence. So this means that this is a line. And remember, I told you early on that for this arithmetic sequence, when you have a line, the slope is equal to the common difference. So I'm just going to find the slope between these 2 points, and I'm going to think about this as like, if it's the fifth term, that means x or t is 5, and then the output y is 12. So I have a point that's 512 and another point that's 2488. So I'm going to use those 2 points to find the common difference, which again is the slope. So I'm going to do 88 minus 24 over, now I'm not going to do time minus 24. I'm going to do 88 minus 12 over 24 minus 5. That gives me 76 over 19, which equals 4. And now I need to find the first term. So there's a couple ways you could do it. You could just keep subtracting 4 from the fifth term to get down back to the first term. That works fine on a problem that's not that far off from the first term. But the other thing you can do is just set up an equation where you're doing some substitution. So again, this is when n is equal to 5. So like we could think of it like this, n comma t sub n. So my formula in terms of t here would look like this. Okay, I know t sub n, I'm going to call it 12. I don't know my first term, but I do know that n is equal to 5, and my common difference is 4. And so now I can just solve for the first term this way. And this is really a useful method when you don't, like when your first term is really far away from what you're working with. So like I was on the fifth term, that's not too bad. But if I had only had like the 12th and the 24th term, that'd be a lot harder. So t sub n here will be equal to first term of negative 4 plus n minus 1 times positive 4. And I believe the problem asked for t sub 12. So I want the 12th term. So I have 44 minus 4, which is 40. So the 12th term is 40, which makes sense to me because it's between 12 and 88. All right, next. This one says find x so that x plus 3, 2x plus 1, and 5x plus 12 are consecutive terms in an arithmetic sequence. So I'm going to think about the fact that the common difference between each of these terms is supposed to be the same. So between the first two and the second two, I should have the same common difference. So if I find the common differences in terms of x, then I can solve for x. So I know that the first common difference would be 2x plus 1 minus x plus 3, second term minus first term. And this should equal the same thing if I were to do the third term minus the second term. So now I've set up an equation related to x. And now it's just combining like terms. Okay, let's see what we get here. So it looks like I get x equals negative 3/2. So then I'm going to substitute that back into these terms that have x's and make sure that it all works. Because it just said find x, so this would be really where you'd stop, right? Assuming it's correct. So if I put negative 3/2 in for x in each of those terms, I get 1.5 as my first term, negative 2 is my second, and negative 5.5 is my third. And if I do the common difference between each of these, so if I did negative 2 minus 1.5, I get negative 3.5. Okay, which is the same as if I do negative 5.5 minus a negative 2. So it worked out correctly. Okay, this one says determine an arithmetic sequence in which the second term is negative 2 and the eighth term is 40. Okay, so a second term is negative 2. So I have the point 2, negative 2. And the eighth term is 40. So I have the point 8, comma 40. I'm going to do the same thing as before. I'm going to find the slope, which is the common difference. So 40 minus negative 2 over 8 minus positive 2. So I get a common difference of 7. And the good news about this one is because I have the second term, all I have to do is subtract 7 from it to get the first term. So I get the first term is negative 5, and then it's n minus 1 times 7. And this is perfectly acceptable. Again, you could write this out in this format if you wanted to. This looks more like a line, right? More like what we're used to with the line, so you could write this down for sure. Okay. I believe this is our last problem. This one says find the common difference in an arithmetic sequence in which the 15th term minus the 7th term is negative 1. So I'm going to write this down a different way so we can hopefully make sense out of it. So we know that the 15th term is when n is 15, and I don't know the answer to that. Oops. So I'm just going to write a sub 15 here. And I have a 7th term, and I don't know it, so I'm going to say a sub 7. But I do know, if I wanted to find the common difference, then what I would do would be a sub 15 minus the 7th term, so the 15th minus the 7th over 15 minus 7. And hey, look at that. I know that a sub 15 minus a sub 7 is equal to negative 1. So I'm going to put that in the numerator, and then 15 minus 7 is 8. So I get negative 1/8 as our common difference. All right. Make sure that you put in the document for questions. If you have any questions, make sure you ask it there.